Okay, today's lesson is on the segment addition postulate with algebra. And our objective today is students will be able to solve for the missing segments using the segment addition postulate. We're going to be adding in some algebra to it. So what is segment addition postulate? We talked about this in last class, but the segment addition postulate, SAP, states that if point B is between point A and point C, then AB plus BC equals AC. If AB plus BC equals AC, then B is between A and C. So in other words, you can prove, if you were given the segment lengths of AB and BC, you can prove that when you add AB plus BC, if it equals AC, then you have proven that B is in between those 2 points. We aren't going to do a lot with proofs for a little bit. We're going to just get some concepts down first, because I think that would be very helpful. All right, so review question number 1. And I even gave you the diagram on this one. Point L is between K and M. If KL equals 3 and LM equals 6, find KM. All right, let's go over this. So majority of you said 9. We had a lot of people not answer, so I'm not sure if it's because we're still a little foggy on this. So let's talk about this. So we have this piece is 3 and this piece is 6. And it tells you that you are finding KM. That's your goal. So I could take my highlighter and say, okay, so K to M, it's the whole thing. So what pieces make that up? Well, I have a piece of 3 and a piece of 6. If I wanted to use the formula, this one would be KL plus LM equals KM. All right, so KL is 3, LM is 6, and that's going to equal our KM. So 3 plus 6 is 9. So 9 equals KM. Hopefully that makes sense for you guys. Does anyone have any questions on this?
Okay. Are we supposed to put the number before the letters or the letters before the number?
You don't have to write all this out for me. I don't require you write the KL plus LM part. I'm just showing you with the formula. Some kids are visual and they do really well with the diagrams, drawing a diagram and just figuring things out with that. Some students prefer to have the formula. So I'm trying to kind of show it both ways. But you do not have to write this part out.
Okay.
Okay, next question. Let's see, and I did not give you the diagram on this one. Remember, you can always draw your own diagram. So I did not set up the pear deck for that, but you can grab a sheet of paper and remember to draw your own diagram. You're just drawing a straight line and putting some points on it and then filling things in that the question gives you. So this question is, point Q is between P and R. If PQ equals 4 and PR equals 13, find QR. I'll give you guys a couple minutes, see what you do with this. All right, let's take a look and see what people put. So we have some answers all over the place, but it looks like more people picked 9 than didn't. So let's try to draw this out. So I'll use the line tool to make my line neat, but you certainly can just, you know, the artistic value of this does not matter. All right, and I'll put 3 points on it. And it says point Q is between P and R. So here's the one that's in between, and PR. Okay, so 1 second. All right, and it tells us PQ equals 4. So here's PQ, so I'm going to label that as 4. And then PR is 13. So I see PR is the whole thing. So 13. And then it tells me to find QR. So that's this piece here. I can highlight that with my handy dandy highlighter. All right, so I know that's what I'm looking for. And you know, go nuts with this stuff. These are very easy diagrams to draw yourself. This is not a lot of work to do. There are definitely some things later on in geometry that would be a lot harder to draw on paper and then really highlight and label and do all of that. But these line segments are pretty easy. Take you about 10 seconds to draw this. But yeah, so to figure this out, we can see the whole rope is 13 feet long. It doesn't matter how you think about this. You can think about it as, you know, a plank of wood, and you're cutting 4 feet off of the end of the plank of wood. Well, how much do you have left? You know the whole thing has to be 13. So really, this is a 13. Go back to green so it shows up a little better. 13 minus 4 is how you would find that, because you're looking at the whole thing and you're just finding this piece. So when you have them together like that, you add them. When you have the whole and one of the pieces, you're subtracting. If that helps. Any questions I can clear up before we start jumping into the algebra part of it? I just got an O from someone, so that's good. Hopefully something just clicked. Something I said finally hit the target, which is always awesome. All right. All right, so now instead of having numbers for the lengths of segments, we will have algebraic expressions. You will use your algebra skills to solve the problems. So here's our first example. I kept the algebra real simple on this one. B is between A and C. Okay, same type of setup as we've seen already. Find the value of X and the measure of BC if AB, this piece here, equals 3, BC equals 4X plus 1, and AC, the whole thing, equals 8. So I went ahead and gave us a diagram to help us. We can see visually everything. Now, nothing has changed in that this piece plus this piece still gives us the whole, still gives us that 8. The difference now is we have this other piece here. So we have to figure out those things. And this is where I start losing students every year. Okay, so it still works the same way. The AB plus BC equals the whole thing. All right, so 3 plus 4x plus 1 equals 8. Okay, see how we got there? Making sense? Any questions? I'm trying to not go too fast, but because once we throw the algebra in. Okay, so we would combine our like terms. Remember, we talked about that very early in the year. And we get 4x plus 4 equals 8. And then we subtract 4 from both sides. So we get 4x equals 4. And then we divide by 4 to get x equals 1. Okay, didn't write all the steps out because once you get here, hopefully everybody knew where to go. So we know x equals 1. Sometimes problems like this will ask you just to find the value of x. And if that's true, then we would be done. But it also says find the value of x and the measure of BC. So we need to figure out what BC is going to be equal to. So to do that, we are going to replace that x in the problem with 1. So we can substitute it in. So 4x plus 1. The x, you always replace your variable. So the x is going to become a 1. So 4 times 1 is 4, plus another 1 is 5. So this piece here, BC, is equal to 5. Hopefully everything's making sense. If anybody's got any questions, I'm all ears. We're going to do one more example together. All right, let me do the second example. So y is between x and z. Find the value of x and the measure of xz. Xy equals 24. So again, gave us a diagram. Yz equals 3x. And xz equals 7x minus 4. Now we have an algebraic expression for 2 of the pieces. Still works the same way. So it's these xy, this piece, so 24, plus this piece, which is 3x, equals the whole thing, which is 7x minus 4. So we still set the equation the same way, it just looks more complicated now, and it does have more steps.
I have a question.
Yes, ma'am.
So that's the answer?
Nope. We gotta do the algebra. But we gotta have an equation to solve. So right now, this part is just setting up the equation. So we know what goes where and what math we need to do. So we have 24 plus 3x equals 7x minus 4. We want to get to the x's all to one side. So we subtract 7x from both sides. So 24 minus 4x equals negative 4. Now we want to get, this over here. So we subtract 24. So we have negative 4x equals negative 28. When you divide by negative 4, you get x equals 7. So that's what x equals. But remember, we want to find the value of x in the measure of xz. So that's the whole thing. So you could go back and you could plug a 7 in and get this answer too. And actually, that would be a valid way to solve the bigger problem. You could actually put a 7 in here and do 7 times the 3 and get 21. So that's a very easy thing to plug into. And then add these two. You could get there that way. Or you could just plug the 7 in here, where you get 7x minus 4. We replace that x. 7 times 7 minus 4. 7 times 7 is 49. And then minus 4 gives you the same 45. I would be fine with you getting there either way. But you don't technically need to solve for yz. In geometry, for most subjects, like most of the topics we're going to talk about throughout the year, it's extremely important to read the question and find out what you need to solve for. So that critical reading skill gets a lot more important in geometry. All right, before we start practice problems, anyone have any questions? Okay, so we're going to move on to practice question number 1. So if M is between L and N, and LM, right letters, LM equals 2, MN equals 4x plus 6, and LN, the whole thing, equals 32, then just find x. That's all you're finding in this problem. So just solve for x. I'll give you guys a couple of minutes to figure that out. Give it a whirl. So, okay. So we can set up our equation. So this piece, 2, plus this piece, which is 4x plus 6, equals the whole thing, which is 32. All right, and I can see I have like terms on this side. So 4x plus 8 equals 32. Now it's just a two-step equation. So subtract 8 from both sides. So 4x equals 24. And then divide by 4. And we arrive at x equals 6. Any questions on this one? Okay, moving on. Here's another one for you. If m is between L and n, and Lm equals 2, Mn equals 4x plus 6, Ln equals 32, then find Mn. And we know already x equals 6. This is the same problem from before, but notice it is different because you are this time finding Mn. That's the part you're finding. And you already know x equals 6. So let's see how we do with this part of the problem. Basically, I took one of the problems from before and split it into 2 pieces. So let's see what we do with this one. Should be okay here. Okay, let's take a look and see. We got one person, need to get that out of there. One person who thought 4, everybody else thought 30. So yeah, you just want to find out what this piece is equal to. You actually don't even need to plug it in. You certainly can and get the 6 times 4 equals 24 plus 6 is 30. But you also knew this piece was 2. So you could have just subtracted the 2 from that because the rest of this has to be 30. As I mentioned in the last class, don't look at drawings and say, well, this is 2. This is like maybe 3 or 4 or something. Like, don't guess based on what they look like. Geometry figure drawings are not always to scale. In fact, there's been quite a few times I've seen geometry problems on things that don't remotely line up. So always use the math. Don't ever assume anything. Make sure you're going on what you're actually being told. All right, let's try this one. If f is between E and G, and EF is 26, and FG equals 5x, EG equals 9x minus 6, find x. So this time you're just finding x. All right, let's see what we got. We have a wide spread of answers. We got a 5, that's probably a 7, maybe 3. And we guess maybe a 9 because it says it's an 8. Okay, that's an 8. I don't know. All right, so there definitely is not a consensus on this one. So let's take a look. All right, so again, we can set it up. It's this piece here, so 26, plus this piece, 5x, equals this whole piece, 9x minus 6. All right, so we don't have any like terms, so we're going to move one of the x's. I typically move the one on the right because I have found over the years students prefer x to be on the left side. It doesn't matter which one you move, whatever is good for you. All right, so now I need to get the x by itself, so subtract 26. So negative 4x equals negative 32. Mind your signs on that stuff. And divide by negative 4. And we get x equals 8, which somebody did have, so good job. You are the master of algebra, sir, or ma'am.
I got it right.
Yay! Good job. All right. Any questions?
Thank you.
Any questions on this? All right, moving right along. So now it's asking you to find EG. So I look at this and that's the whole thing. And it tells you X equals 8. So go ahead and see what you can figure out. Give you a couple minutes on this. So, oh, gotta erase my stuff. So most people said 66. Good job. You can get there a couple of ways. You can, you could have popped in the 8 here, got 40, and 40 plus 26 is 66. Or you could have just plugged it into the expression for the whole thing, and you would have gotten 72 minus 6, which is 66. Either way should get you there. Hopefully this is making sense, but do you have any questions? So we're going to do one more. Well, one more set, one more where we solve for X and then we solve for a piece. Okay. All right, so didn't give you a diagram on this one. If U is between T and V and TU equals 2X, UV equals 26, TV equals 13X minus 7, find X. So if it helps you, draw your own diagram. A lot of times geometry things, they don't give you the diagram and they want you to draw it yourself. I probably won't do that with really complicated ones, but this is literally just remember, you're just drawing a line across, putting 3 points on it, and then putting stuff in yourself. So give you a few minutes on this. All right, if I was going to draw my diagram, all right, put my 3 points, because I'm dealing with 3 points. All right, if U is between T and V, so I know I have a T, and I know U is in the middle, and V. And TU equals 2X, and UV equals 26. And it says TV, which is this whole thing, which, you know, makes it sound so much more exciting than this. It's TV now, but anyways. All right, 13X minus 7, find X. So I know this piece plus this piece equals this piece. So I get 2X plus 26, and that equals 13X minus 7. And now I'm going to go ahead and I'm going to check both sides. There's no like terms. And now I want to get all the things on one side. So minus 13X to both sides. So that gives me negative 11X plus 26 equals negative 7. All right, and then I subtract 26 from both sides. And negative 11X is negative 33. Divide by negative 11. And you should have gotten X equals 3.
I got it right.
Yay! I'm so excited. Good job. A few other people did too, so that's great. Or they just saw where I was going and they clicked in the 3, because I can see on my other screen. But that's okay. I'm glad you're following along. Cool. Any questions on this before I clear all these drawings and all this nonsense? All right, we're going to skip the second part of the question because we have 1 minute left, and I'm really trying to stick to the time, guys. All right, summary. When solving a segment addition postulate problem involving algebra, if there's no diagram, it might be helpful to draw one. I highly recommend it. Some kids genuinely don't need it, but most kids benefit from it. Pay attention to which number, letters, or expressions go where in your equation, and pay attention to what the question is asking you to solve for. All right, our big check-in. How do you feel about today's lesson? Let's see where you guys are at with this.